ಗುಡ್ ಈವ್ನಿಂಗ್ ಆಲ್ ಆಫ್ ಯು. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಇಂದಿನ ವಿದ್ಯಾರ್ಥಿ ಪ್ರತಿಭಾ ಶೋಧ ಯೋಜನೆಯ 67ನೇ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಶ್ರೀಮತಿ ಚೈತ್ರ ರವರು ಅಮೈನ್ಸ್ ಎಂಬ ವಿಷಯದ ಮೇಲೆ ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದು, ಅವರನ್ನ ಈ ಒಂದು ವೇದಿಕೆಗೆ ನಾನು ಸ್ವಾಗತಿಸುತ್ತಿದ್ದೇನೆ. ವೆಲ್ಕಮ್ ಟು ಯು ಮ್ಯಾಮ್.
Thank you, sir. Thank you.
And I also welcome to all the attendees and the participants of this webinar session. ಸೊ ಇದು ಹಾಜರಾಗಿರ್ತಕ್ಕಂಥ ನನ್ನ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಶಿಕ್ಷಕರು, ಅಧ್ಯಾಪಕರು ಹಾಗೂ ನನ್ನ ಸಹೋದ್ಯೋಗಿಗಳನ್ನು ಕೂಡ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತ ಮಾಡುತ್ತಾ, ಕಳೆದ ತರಗತಿಗಳಲ್ಲಿ ಈಗಾಗಲೇ ಚೈತ್ರ ಮೇಡಮ್ ರವರು ಹಲವಾರು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಗಳನ್ನು ಈ ಒಂದು ವೇದಿಕೆಯಲ್ಲಿ ತಮಗೆ ಕೊಟ್ಟಿದ್ದು, ಕಳೆದ ತರಗತಿಯಲ್ಲಿ ಚೈತ್ರ ಮೇಡಮ್ ರವರ ಬಗ್ಗೆ ಅವರ ಕಿರು ಪರಿಚಯವನ್ನು ಮಾಡಿಕೊಟ್ಟಿದ್ದು, ಸಮಯಾವಕಾಶವು ಬಹಳ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಸೊ ಈ ವೇದಿಕೆಯನ್ನು ಅವರಿಗೆ ನಾನು ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಓವರ್ ಟು ಯು ಮ್ಯಾಮ್.
Thank you, sir. Thank you.
Please you ask some questions, ma'am.
Yes, sir. Yes, sir. Sure.
Yes. Okay. Thank you. Over to you, ma'am.
Yes, sir. Thank you. Hello, students. Good evening. Today we will be learning about an important chapter in organic chemistry, that is amines. So as soon as you hear the name amine, since in first year and all you would have learned about nomenclature. So at Gottirodrinda, you know that there is a functional group which is called as amine, right? So I hope you remember NH2 functional group, nitrogen and H2. This functional group is called as amine group, right? You would have used suffix name as amine. So basically this amine is a class of organic compound which contains NH2 as the functional group. Okay, so today we'll try to understand the introduction about amines, classification and its preparation methods. So let us go according to NCERT itself. Before starting with amines, preparation and all, I just want you to know few important things about amines. Like if you tell amines, this is the functional group, correct? But there are so many other functional groups also which contains nitrogen also. So those are nothing but, for example, if I write instead of NH2 NH, this becomes a secondary amine. Yes sir.
ನೀವು ಬೋರ್ಡ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರಿ ಇವಾಗ?
ಎಸ್ ಸರ್, ನಾನು ಬರೀತಾ ಇರೋದು ಕಾಣಿಸ್ತಾ ಇಲ್ವಾ?
ಇಲ್ಲ ಇಲ್ಲ ಇಲ್ಲ, ಅದಕ್ಕೋಸ್ಕರ ಇದೊಂದು ಸ್ವಲ್ಪ ನೀವು ಮಿನಿಮೈಸ್ ಮಾಡಿರಿ.
ಓಕೆ. ಓಕೆ, ಆ ಪಿಪಿಟಿ ಕಾಣಿಸ್ತಿದೆ ಅಲ್ವಾ ಸರ್?
ಅದು ಪಿಪಿಟಿ ಕಾಣಿಸ್ತಾ ಇದೆ,
ಬಟ್ ಅದ್ರ ಮೇಲೆ ಬರೀತಾ ಇರೋದು ಕಾಣಿಸ್ತಾ ಇಲ್ವಾ?
ಈಗ NH2 ಬರ್ದು ನೀವೆಲ್ಲ? ಎಸ್ ಎಸ್ ಕಾಣಿಸ್ತಾ ಇದೆ.
ಎಸ್ ಸರ್.
ಓಕೆ ಓಕೆ, ರೈಟ್.
Okay sir, thank you sir. So here nitrogen will be attached to one single carbon atom, so it is called as a primary amine. Now in this case, second case, whatever I have written, nitrogen is directly attached to two carbon atoms, so I can call it as a secondary amine. So under amines only you have so many functional groups actually. Okay, so if I write nitrogen and 3 bonds like this, because the valency, general valency of nitrogen is 3, I call this as a tertiary amine. Okay, so this is a secondary amine, this is a primary amine. And also we have other classes where nitrogen also there. This is cyanides. Through nitrogen, if the linking happens, it is called as isocyanide or isonitrile. Similarly, you have a nitro group. Through nitrogen, the linking happens, nitro group. Through oxygen, the linking happens, it is called as nitrite. And you have diazosalts also. So all this you will be using in this entire chapter. Okay, so let us start with just knowing what are the important details of amines. So actually these amines are part of plants as well as animals. So now I have put few pictures here. If you are able to see this, you can observe this is dyes, artificial dyes, whatever I have written. So that is prepared by coupling reactions. Okay. So in this also you will have nitrogen or azo group will be there. And this is a hormone I have written in biology. You would have come across adrenaline. It is a flight, fight, response hormone, right? See, you can see here nitrogen is present in this case also. And this is vitamin B12. All of you know it is very important for our life, vitamin B12. It is also called as cyanocobalamin. So you can clearly understand that in this also amine group is there, right? And yes, many of you would have taken cough syrup, right? Benadryl. So here I have put different pictures. One is for dry cough, wet cough, as well as for kids. So these components are used. So in this also, amine group will be there, one of the component. And this is called as novocaine. Novocaine is actually used as anesthetic agent in dentistry. So if you have visited ever dentist, sometimes with, if you have to fix with ceramic teeth, if you have lost normal teeth, so then you have to undergo some drilling and all, and you have to get the treatment, right? So that time anesthesia is used. So novocaine is one among that, and that also contains amine group. And why all those things? You know very well about RNA and DNA, right? So these are made up of nitrogenous bases, right? So here, cytosine, guanine, adenine, uracil, you can observe clearly in these cases also you have amine groups. So it plays a very important role. And this is a picture to denote surfactants I have put. So all of you use detergents to wash clothes, right? Detergents. So one of the important cationic detergent is cetyl trimethyl ammonium bromide. This is the formula of that cetyl trimethyl ammonium bromide. See, this is a salt of amine itself. Nitrogen you are seeing. This is called as a cationic detergent. Uh, this is actually used in hair conditioners and all, to wash hair conditioners. It smoothens the texture of the hair, right? And these cationic detergents or surfactants are little bit expensive, so it is under limited use. Okay, and yes, this is a picture which denotes vitamins. So vitamins, in the name itself, vital amines is there. But not all the vitamins contains amine group. It is the misconception. Still, we are carrying the same name. But many vitamins contain amine group. One among that is cyanocobalamin, which is vitamin B12. Right, students? And here I have put a picture which denotes fish, right? So why I have put this? As we are studying amines chapter, all of you know that amines are basic in nature and they have a strong odor. If I ask what is the odor of amines? Yes, students, how they smell? They have fishy odor. Okay, so the fishy odor is because of TMA. TMA stands for trimethylamine. It's a tertiary amine. Okay, so that's why amines are in fishy odor. Okay. Yes. So this is a little introduction why amines are so important in so many components or so many substances in day-to-day life. Whatever we use, it may contain amines. There are polymers which is nylon 66. All those, they are used in textile industries as well as in the raincoats, They will use nylon. Nylon contains nitrogen or amine group. In parachutes, airbags, seat belts, in all those cases, they will be using, yes, nylon. So this is the little bit introduction about amines chapter. Let us move on to the classification. Before going to classification, just I'll define what are amines. So basically, amines are nothing but aliphatic or aromatic derivatives of ammonia. So all of you know this is ammonia, right? What is the hybridization of nitrogen in ammonia? Yes? Yes, you can answer. Nitrogen hybridization. You would have learnt in chemical bonding chapter, right? You can use this formula. H is equal to half into V plus M. Yes, very good. Yes, we have answer from Kirana. Yes, sp3 hybridization. So you can use this formula where central atoms hybridization you have to calculate. Yes, nitrogen's valency or valence electrons is 5 plus monovalent atoms surrounding nitrogen is 3. So no cationic anionic charge is there. So it is 8 by 2 means yes, it is 4. 4 is the number means it is sp3 hybridization. Very good. Now what I'm going to do is I'll replace hydrogen, keep substituting with some other groups. If I, in case, remove one hydrogen and substitute it with R, then I call this kind of amine as alkyl amine. Okay, R stands for alkyl group. Alkyl group can be CH3, C2H5, C3H7, butyl group, pentyl group, isopropyl group. It can be anything. Now, secondly, I will replace one of the hydrogen by a aryl group. Aryl group means C6H5 group. Okay. You can also write like this. Instead of AR, benzene ring you can write and write this. This is called as aromatic amine. Aromatic amine. Or you can also call it as aryl amine. Okay. So what is the definition of amines? They are aliphatic or aromatic derivatives of ammonia where one or more hydrogens are replaced by aliphatic or aromatic groups. Okay. So let us briefly understand the classification. Then directly I will take you through the preparation methods of amines. Okay. So firstly, based on substitution by different groups itself I will take. So let me write here. I will write the first classification of amines. First classification. This is based on substitution. Substitution of hydrogen by alkyl group or aryl groups. Okay, different examples you can write. Now, I'll take ammonia itself for comparison. Write ammonia. If I don't write also, you have to imagine here lone pair of electrons will be there because nitrogen valence electrons, you know, 5. They are involved in the bonding. So remaining 2 electrons will be present as what, students? Lone pair of electrons. Okay. Now what I'll do? I will just keep replacing hydrogens by either alkyl group or aryl group. Okay, first case I will take. I will replace one hydrogen by R group. Here NH3 is there, no? Remove one hydrogen, attach by R group. Now I am replacing one hydrogen. Okay, so what do I get? RNH2. Okay, R group is alkyl group. If I write AR group, it is aryl group. If you replace one hydrogen and attach AR, it becomes aryl amine. Okay, students. Now you see, nitrogen is directly attached to how many carbons here? Here, it is directly attached to one carbon. Okay, let me write example. Then you will understand in a better way. I am writing CH3 NH2. Now, can you tell me nitrogen is directly attached to how many carbons here? It is one carbon, right? So, this is called as primary amine. If nitrogen is directly attached to one and only carbon, then you will call it as primary amine. Okay. Now, here, you replace 2 hydrogen by R group. Now second case what I'll do, I'm replacing 2 hydrogens. So I'll remove 2 hydrogen and attach R group. What will be left out here if I replace 2 hydrogens? Only 1 hydrogen, right? I'll get like this. On a nitrogen, lone pair will be there. Now can you tell me students, what kind of amine is this? Nitrogen is directly attached to how many carbon atoms here? Okay, take an example if you get confused. So I will write CH3, NH, CH3. Can you identify here nitrogen is directly attached to how many carbon atoms? Yes, very good, Jyoti. So it is secondary amine. Okay. So similarly, third case, I'll replace 3 hydrogen atoms. Okay. So I'll get nitrogen, lone pair will be there. So here I'll write CH3, CH3 and CH3, right? So this is an example for what kind of amine? Yes, it is tertiary amine because nitrogen is directly attached to 3 carbon atoms. Now last case, what I'll do is here lone pair of electron is there. Now I'll add a proton for this. For this ammonia, you instead of adding proton, you can do this thing. Here I attached 2 R groups. Here I attached how many R groups? 3 R groups, right? Now you take 4 R groups and attach to nitrogen. 3 R groups you will write here. But the fourth one utilizes this lone pair of bond. And
Hello.
now lost electron, right? Lost electrons. So it carries what charge, guys? It carries positive charge. So this is called as quaternary ammonium ion, right? So these are the classification of amines by just replacing hydrogen. I have primary amine, secondary amine, tertiary amine, and quaternary amine. Fine. So,
Chaitra madam.
yes, sir.
Somebody they answered through chat
Yes,
box.
sir. Yes, sir. I saw 2 times they answered.
Yes, yes, please. Okay, thank you.
Yes, sir. Thank you. Okay, guys. So next, let us move forward. Let me give one example to you. Okay. Okay. See, one thing you understand, if I write CH3NH2 like this is a primary amine. Okay, because nitrogen is directly attached to one carbon. Can you tell me, guys, if I write this general example, what kind of amines? You have to tell me all these are what kind of amines. I have given 4 examples to you. You have to answer me what kind of amines are this. Can you identify what kind of amine is this? First one is very simple. It is a primary amine. Right? You have to answer, guys. So here nitrogen is directly attached to how many carbon atom? Yes, it is a primary amine. Now, if you have any confusion, this you cannot identify as secondary and tertiary. Now you observe nitrogen is directly attached to only one carbon atom. So this is also primary amine. Here nitrogen is directly attached to single carbon atom. This is also primary. So all these amines are primary, but this carbon is primary. This carbon, can you tell me what is the nature of this carbon, guys? This carbon is directly attached to how many carbon atoms? More. It is attached to 2 carbon atoms, right? So it is secondary. So this carbon atom is directly attached to how many carbon atoms directly? This is tertiary carbon. But what kind of amine is that? It's a primary amine. So just have a note of these things. Otherwise you will get confused. Okay. So here also I can tell here only one more classification I can tell. Amines are also classified into aliphatic and aromatic amines. Aliphatic and aromatic. Aliphatic means open chain. So if I write CH3NH2, it is aliphatic amine. If I write benzene ring and attach NH2 group for that, I can call this as aromatic amine. Okay. So this is one more classification. So already I told you spoke about the hybridization. So if I take ammonia, what is the hybridization of nitrogen? sp3, bond angle is 107 degree. All this you have studied in chemical bonding chapter. So similarly, amines also show sp3 hybridization. Okay. So let us directly start with the preparation method. Before that, I'll give one or two examples for nomenclature, how to give the nomenclature with respect to common and IUPAC name. See, for example, first one, I'll take CH3NH2. How do you give the common name for this? Can you tell me the common name and IUPAC name? Common name and IUPAC name. You have learned the rules. Try to recollect. Yes, very good. Yes, Lakshmi, it's very good. It's methylamine, correct. This is methyl group. This is amine group. So common name is methylamine. Whereas IUPAC name, to tell that you have to remember about root word. Yes, very good. Lakshmi has answered. It is methenamine. So one carbon atom is there. Root word is methane. But you should not tell methane amine. Methane plus amine you should not tell. You have learnt a rule that whenever the suffix name starts with an vowel. Now this group, what will you identify as? Amine, right? So if it starts with an vowel, A, E, I, O, U, in that case, what are you going to do? You are going to avoid this E and write methane amine. That's the IUPAC name, right? So you should know the nomenclature in order to write the reaction. For example, I'll take this. Can you answer this? What is the nomenclature for this common name and IUPAC name? So how many carbon atoms are there here? 1, 2, 3. But is this normal propyl or isopropyl group? If we have an open V structure, this is an example for isoprefix. Okay, this is called as isopropyl amine. Isopropyl amine. Can you tell me the IUPAC name for this? IUPAC name means you have to select the longest chain. Select the longest chain. From where will you start the numbering? 1, 2, 3. So I will call this as propan. Propan. What is the position of the amine now? Amine group 2. Amine. Propan 2 amine. Or you can also call it as 2-propanamine, but this is the best way of nomenclature. Okay. So basic nomenclatures are important. When I deal with the preparation only, I will give the example. There only I'll tell you the nomenclature also. Yes. Okay, guys. Now next, you take the preparation of amines. So totally how many methods are there? 6 methods are there in NCERT. So in today's class, we will explain the preparation of amines. Okay. So the first method of preparation, I will consider Hoffman's. Hoffman's ammonolysis method. Ammonolysis. Okay, Hoffman's ammonolysis. It is the scientist name. It's a named reaction basically. So what exactly happens here is, I'll take the starting material as Rx. Can you tell me what is Rx? Rx is the general formula for what? Yes, this is an alkyl group. X stands for what in organic chemistry? Very good, Jyoti. Alkyl halide. So this is an alkyl halide I have taken. And I will take ammonia. I'll treat this alkyl halide with ammonia, alcoholic ammonia. It is the solvent for the reaction. On the aroma, I'm writing 373 Kelvin as the temperature. You have to maintain this temperature. In a sealed tube, you have to conduct this reaction. Now you tell me what happens. You know that alkyl halide is polar in nature, right? Who is more electronegative among R or carbon and halogen? Halogen is more electronegative, right? So it pulls both the electrons towards itself. So this get partial negative charge, this get partial positive charge, right? Now this became electron deficient. Now here is the nucleophilic reagent. So this will attack this position and you get RNH3 attach that Now nitrogen lost electrons, so write positive charge. So here halide ion is there, it stays in the vicinity of the positive part only. This is nothing but primary, because nitrogen is directly attached to how many carbon atoms? 1. So this is called as primary ammonium salt. Primary ammonium salt. Now, if you treat this with a base, strong base, you can regenerate whatever the amine is formed. Okay, so I will show in a simpler manner how the reaction works. See, you take this and treat it with a strong base, NaOH. How NaOH ionizes, guys? Na plus and OH minus. Now, what will form is, see, nitrogen has positive charge, so deprotonation happens. You get RNH2 plus, you have H plus coming out to neutralize that positive charge. That bonded pair of electrons will take H plus and OH minus goes out as water, and Na and X will liberate as NaX. So what is this? You got primary amine. But the speciality of this reaction is, you would take alkyl halide in excess. In excess you will take. Okay, so the reaction continuously happens till all the hydrogens are replaced. Now what will happen? In a simpler manner, I will show you how to write the reaction. Take Rx. You should always take alkyl halide only. Can you take aryl halide for this reaction, guys? Think and answer me. Okay, here I have written alkyl halide, right? Instead of this, if I take aryl halide, will the reaction happen? Aryl halide means this one. Benzene ring directly attached to halogen. Can I take this as the starting material for Hoffman's ammonolysis? Yes or no? Think. Can I take that? No, right? Why? Why you can't take? Because it is not easy to cleave the carbon halogen bond in the haloarene, right? Because of the partial double bond character as well as sp2 hybridized carbon, you can't cleave the bond easily. Okay, remember alkyl halide alone you have to take. Now, instead of writing directly NH3, I have opened and written like this. Now, obviously, you have to heat it. Now, you remove HX. Keep doing this reaction till all the hydrogens are replaced. Now, can you tell me what is the product formed in this case? I get RNH2. I got primary amine in the reaction. Now, next step. Again, I have taken excess alkyl halide. Can you tell me what is the product in the next case? I took Rx. So from here 1H, from here X I will replace. HX will go out and I get RNHR. So what is the nature of this amine? Nitrogen is directly attached to how many carbon atoms, guys? It is secondary amine, right? Now on the arrow mark, once again I'll write Rx. So please predict the product. What might happen? See here, one more hydrogen is left out, right? Can you tell me what product forms? Remove HX. Yes, what kind of amine is that? Now I get R, N, R, R. Yes, what is the nature of the amine? Nitrogen is directly attached to how many carbon atoms? 3. So this is called as tertiary amine, right? And at last, what will I do? Again, treat this molecule with one more mole of alkyl aldehyde. Now, yes, here R plus is there. No, this will take this lone pair of electrons and form R 4 times. R 4 times in. On nitrogen, what is the charge now? It is positive charge. So this is called as quaternary ammonium ion, or this X minus comes and stays with the in the vicinity of the N plus. So you call it as quaternary ammonium salt. So this is a very important reaction. It's called as Hoffman's ammonolysis, which happens through nucleophilic substitution reaction. Okay. So let me show one example to you. Then you will understand in a clear manner. So now I used alkyl halide, right? Can you tell me what is the reactivity order of alkyl halide, guys? X stands for what? Halogen. So what are the halogens you have seen in periodic table? 17th group elements, fluorine, chlorine, bromine, iodine. We don't take acetine and tennessine and all. You can remember fluorine to iodine. Can you tell the reactivity order of this alkyl halides? Who should be more reactive and why? Why Ri is more reactive? Yes, why? Because R is common in these cases. Halogen down the group size increases. Who is bigger here? I is bigger, right? So bond length and bond dissociation enthalpy, how they are related? They are inversely related, right? Now you tell me where I can cleave the bond very easily. This one, right? Because size is bigger, bond length will become bigger. So bond dissociation enthalpy is lesser. Therefore, this is most reactive. Okay, take an example. I will take C2H5I as the alkyl halide plus ammonia halide. Can you complete the reaction and tell what in all forms here? Keep removing HI, that's it. Yes, keep telling what is the product. C2H5. Yes, what will I get? NH2. So what is this called as? Primary amine. Next again on the arrow mark I will take C2H5I. Once again remove HI. What is the product I'll get? C2H5. What is remaining guys here? NH. This side already I have removed. So attach C2H5. What kind of amine is this? Secondary amine. Once again on the arrow mark you take C2H5 I. So you will remove HI and you get C2H5 and C2H5 C2H5. Nomenclature also is important. Keep telling guys, this is ethylamine, this is diethylamine, this is triethylamine. Once again on the arrow mark write C2H5. So what will happen? You get C2H5 4 times N plus and I minus. This is quaternary ammonium iodide. So tetraethyl ammonium iodide salt. So any doubts in this guys? Understood, right? Now is this a good method for preparation of amines? That's my question. Is this a good method of preparation of amine? Yes or no? Answer. This is a good method. No, right? Because you're getting mixtures. So once you get mixture, again you have to separate everything if you want primary amine, secondary amine and all. So this is not a good method. It's not a preferred method. Why it's not a good method? Because it is mixture. It yields mixture. Again, separation is difficult. Separation is difficult. So this is all about the first preparation method. Okay. So this is the first preparation method, that is Hoffman's ammonolysis. Remember what are the reactants? Alkyl halide and alcoholic ammonia you will take. Substitution happens. You keep getting primary, secondary, tertiary and quaternary amines. So let us move on to the second method of preparation, right? So second one is, now purely I will prepare only primary amines, okay? In our syllabus, we have preparation of primary amines alone, no preparation of tertiary and all. So let us start this. So under this, you get reduction of nitro compounds. Reduction of nitro compounds. Nitro group means what? NO2 group. Okay. So reduction means I have to use a reducing agent. Which are the important reducing agents which are used for this reaction means I can use hydrogen in the presence of platinum or hydrogen in the presence of platinum or palladium or nickel. This works as a reducing agent. Then you can use tin HCl. These are also good reagents. Also, you can use iron in HCl, Fe in HCl. All these reagents you can use. These work as what, guys? Reducing agents. Okay. So general reaction I'll write and show it to you. It's very simple. Take starting material as RNO2. This is RNO2 nitroalkane. I'm taking On the arrow mark, write any reducing agent. You can write H2 bar PT also. So basically, you will be reducing this group. So here only you remember of NO2 group reduces to what? Reduces into NH2. So can you tell me the product? If I take nitroalkane, what will be the product in the reaction? Can you identify, guys? NO2 group should get reduced to what? NH2. So can you identify the product in this case? It is no ascent or descent of series. R remains the same. NO2 alone gets converted into NH2. That's it. What is this? We prepared amine. So I'll ask you now some questions with respect to example. You predict the product. Let me take CH3NO2. Can you tell me what is the name of this compound? Nitro group cannot be used as suffix. It has to be used as prefix only. So can you tell me what is the name of this compound? CH3NO2. It is nitro. How many carbon atoms are there? One. So it's called as nitromethane. Can you tell me what is the product? What did I tell? You have to just convert NO2 group to NH2. Yes, can you tell me the product, guys? Yes, I'm waiting. Tell. NO2 will get converted into what? That's it. Very good. Yes, Lakshmi, very good. CH3, NH2. This is methanamide. Now, if I have C2H5, C2H5, NO2, just you convert NO2 group to NH2. That
ಚೈತ್ರ ಮೇಡಮ್ ಅವರೇ,
yes, sir.
ಬೇಕಾದ್ರೆ ನೀವು 5:15 ಮಾಡ್ಬೋದು, ಏನ್ ತೊಂದರೆ ಇಲ್ಲ.
Okay, sir. Okay, sir.
Okay, please.
Yes, sir. Thank you. Yes, C2H5, NH2. So this is nothing but ethylamine, right? So one more example I will write here. You identify the product. So this is cyclopentane. Now I have attached to NO2 group. So what is this called as? This is called as nitro group is there, cyclopentane ring is there. Okay, so this is tin in HCl. This also work as reducing agent. Now you just convert that NO2 group to NH2. You get what? Pentanamine. That is the IUPAC name of this compound. Okay, so one thing you have to note in this reduction of nitro compounds is, see, among all these reducing agents, which is used as the best reagent means this one. Please have a note of this. Iron. This is also nothing but scrap iron. Scrap iron means like they would have divided that iron into some turnings, like copper turning test and all you would have done. No, scrappings of iron, you remember. Why this works as a better reagent? Why means, if you conduct the reduction of this nitro compound with iron scrappings and HCl, what will happen is FeCl2 will form. You know, if Fe reacts with HCl, FeCl2 will form, right? The formed FeCl2, it gets hydrolyzed. It gets hydrolyzed and again it releases HCl, more and more HCl. So even if you start the reaction with small amount of HCl, the reaction is going to happen. Okay? Even if you start with a small amount of HCl, since this Fe reacts with HCl, it will form FeCl2. The formed FeCl2 get hydrolyzed to give more and more HCl. Even if you start the reaction with smaller amount of acid, the reaction can easily happen. That's why this reagent works the best. So have a note of that. Fine. So this is one more method of preparation. And one more note, what you have to take under this reaction is, I told the reducing agents used are these things, right? In case, if you use like lithium aluminum hydride and all, such kind of reducing agent, because you know about that also, no? Rather than you getting amines as the major product, you get azo compounds as the major product. Just have a note of that. So otherwise, this reaction is very simple. You start with nitroalkanes, you end up getting amines. Simple. Okay. Let us move on to the next reaction. Next preparation method for amines. So I'll take reduction of, mostly many reactions are reductions only here, reduction of nitriles. Can you tell me what is the functional group here? Nitriles means what is the functional groups, guys? Answer. There is a name also for this reaction. It's also called as Mendius reduction or Mendius reaction. Yeah, speak. Amine means you told the functional group is NH2. What is nitrile means? It is CN group. Isonitrile means it is NC group. Right? Now, here also the reducing agents are, you can take hydrogen in the presence of ranitidine. Ranitidine is nothing but an alloy of nickel and aluminium. So that would work for the yielding of better amount of the product. And you can also take sodium in ethanol. This also works as reducing agent. Okay. So you can also take other reducing agents like lithium aluminum hydride. It is also very strong reducing agent, but you know that lithium aluminum hydride is little expensive. Okay. So let us try to understand this reaction. So what is the general formula of nitrile means? I'll write it as RCN. I'm taking alkyl nitrile only. So this is called as alkyl nitrile. Now between carbon and nitrogen there is triple bond. Okay. Now what I have to do? I have to do reduction. Can you tell me in terms of redox chapter you have learned the classical idea of oxidation and reduction. What is reduction? Yes, what is reduction? You know that oxidation is loss of electrons, reduction is gain of electrons, that is in terms of electrons. Can you tell me the classical concept? In organic chemistry and all, what will we use? Addition of oxygen is called as oxidation, whereas addition of hydrogen is called as reduction, right? Now I have to add across the triple bond. Yes, very good. Addition of hydrogen. Yes, Jyoti. Yes. Now I am taking reducing agent. They serve hydrogens. So I have to add across the triple bond hydrogens. So on the aroma, you write any reducing agent you want. Either you can write lithium aluminum hydride, or you can write sodium in ethanol, or you can write hydrogen in the presence of catalyst also. Now you have triple bond and sigma and pi bonds, right? Which bond you can cleave easily? Pi bonds are weaker, right? So cleave this bond, add H and H here. Will the valency of carbon satisfy? Okay, nitrogen satisfy. So here what happens? In order to break it and make it a stable product, I'll add one more mole of hydrogen. So basically I'll add 4 atoms of hydrogen here. So I broke both the pi bonds. Now what I have product R CH2. Now single bond, you write, because I have broken these 2 bonds and I got NH2. See, this is a method of preparation of, once again, primary amine. So I started with alkyl nitride. I got a primary amine. Very simple. So let us take one more example. You tell me what is the starting material name. You can directly write CH3CN like that. You need not show this triple bond, but it becomes easy for you to predict the product if you write like this. That's all. So what is the name of this? You can call methyl nitrile also or methyl cyanide also. One of the important common name for this is acetonitrile. Acetonitrile, right? So you add hydrogens and tell me the product. Yes, I took acetonitrile upon reducing or treating with reducing agent. Yes, what is the product? Name of the product. It's so easy. You just have to add across triple bond hydrogens. So can you tell me the product? You break these bonds and add this side one hydrogen, hydrogen. Here also one more hydrogen. Here also one more hydrogen. So what do I get? CH3. Yes, very good, Lakshmi. It is ethanamine. CH3, CH2, single bond, NH2. Fine. This is called as ethanamine. Fine. So nomenclature, you know very well. So one more example I'll give. If I take benzene ring and attach C triple bond in here, what is the name of this compound? It is called as benzonitride. Now, on the arrow mark, take any reducing agent and please tell me the product. What do you get? I have benzene ring as it is. Now you add across the bond hydrogens. Yes, add and tell me the product. What do you get? Benzene ring CH2. What is this group called as, guys? Benzene ring directly attached to CH2 is called as. Yes, it is benzyl. Okay. Now here I have NH2. So this is nothing but benzylamine. This group is there, no? This is called as benzyl group. So this is called as benzylamine. Okay. One connected reaction I'll give you. Try to understand this and solve it. I will take starting material as ROH. Okay. This is an alcohol. On the arrow mark, I will write SOCl2. What is SOCl2? It is thionyl chloride. I hope you would have studied in haloalkanes chapter. This is called as a Dawson's reaction. So what is the product here? What do you get? Product ROH is substituted by Cl. You get RCl. Alkyl halide you will get. And the byproducts you will get it as HCl and SO2. That's why you will tell this is a very good method to prepare alkyl halides, right? Remember? Now, on the arrow mark, I'll write KCl. Can you tell me what is the product? Predict the product. Yes, predict it quickly. KCN is an ionic compound, right? How it ionizes? K plus and Cn minus. This is the ambidended nucleophile. Very good. Yes, Jyoti, it is RCN. So, why the linking happens through C? Because carbon-carbon bond strength will be greater. You get alkyl cyanide. Very good. Okay. Now, next on the arrow mark, I'll write lithium aluminium hydride. This is a reducing agent. Now, identify the product. See how they can ask the connected questions for you. So, what this group will be converted into? This group will be converted. You just add hydrogens. No, you get R, CH2, then NH2. So this is how amines can be prepared. So this is one more method. Okay. Let me go over the next method of preparation of amines. I'll take by reduction of amides. Reduction of amides. What are amides? Amides. What is the general formula of amides? RCONH2. This is the formula for amide, right? So now let me take one general reaction. R C double bond O NH2. Valency of the carbon I have to satisfy. That's why I'm writing like this. Now again follow the same thing. You can take reducing agent and remember upon reduction C double bond O group will be converted into what? Can you tell me? CH2. Okay. In aldehydes and ketones also you would have done Clemenson's and Booth-Kishner reduction and all. No. What will C double bond O group reduce to? It will get reduced to CH2. That's it. Reduction of amides. So I'll write on the arrow mark lithium aluminium hydride. Predict the product means what will you do? From amide to amine you should get. So what will you do? R C double bond O is there, no? That you make it CH2 so that you get primary amine. So let us take one example. CH3 C double bond O NH2. Can you tell me the name of this? Yes. Yes. How many carbon atoms are there? Numbering should be done in this way. How many carbon atoms? 2. Can you tell me what is this functional group called as C double bond ONH2 amide? So what is the IUPAC name of this compound? Think and tell me. Yes. 2 carbon atoms means what is the root word? Ethan. Okay, very good, Jeevan. Yes, ethanamide. Correct. Can you tell me common name for this? CH3CO group is there. Means what do you call it as common name? Yes, guess. Okay, I'll only tell you. It is called as acetamide. Okay, remember that. Sometimes they'll ask of reaction in terms of common name also. Now, can you tell me the product? That's it. Any reducing agent, you take sodium and ethanol or lithium aluminum hydride and tell the product. You start the reaction with acetamide or ethanamide. What is your ending product? It is CH3NH2. Very simple, right? You just reduce this group into CH2. Got it? Any doubts? So this is nothing but, I'm sorry, this you have to convert into CH. No. So you will get ethylamine. You just keep it CH3 as it is and C double bond O, you convert it to CH2. So you get ethanamine. So this is another method of preparation. Okay, very good, Lakshmi. Okay. So next, these next fifth and sixth preparation is very, very important. So clearly understand. So next, it is also a named reaction. Hoffman's bromamide, Hoffman's bromamide reaction, or you can also call it as Hoffman's bromamide degradation. Degradation. So here you will take the starting material as amide, okay, and you convert that amide to amine, amide to amine. That's it. What is the difference you are seeing? Earlier case, you took amide and reduce that C double bond O group to CH2 and made a amide. Now what am I doing? I'm removing a carbon atom. Okay. So amide means CONH2 functional group will be there. So I'll take this. But what will I make? I'll make amine. So I'm removing one carbon atom. Keep that in mind. Okay. So let me write the general reaction so that easily you can write the products. So I start with R C double bond O NH2. So what is the name of the starting material? It is amide, general amide. Plus, what are the reagents taken for Hoffman's bromide reaction means you have to treat this amide with bromine. Okay, that is the reagent. You have to treat it with that only. Plus, I will take a strong base, whether it is KOH or NaOH, anything you can take. So I require 4 moles of KOH. I'll write KOH only. Okay. Now, next on the aroma to show heating symbol. Now you tell of me the product. What should be the product? See, look here. This is the general idea you should have. That's it. You take amide, you make amine, just remove this part. That's it. Yes, Anilin, how is it possible? It is amine, right? So I get RNH2. Yes, yes, correct. So plus byproducts are also possible. If you write the mechanism, you will understand. But if you write byproducts directly, you have to remember as it is. Otherwise, you will write mechanisms, you will understand each and every step. Yes, Jeevan, correct, very good. So, since I have taken potassium here, I'll write K2CO3 plus I also have KBr and also water is the byproducts. Just balance the reaction. So, it is 2 KBr and 2 H2. Fine. So amide and what are the other reagents for Hoffman's bromide reaction? Bromine and a alkali, strong alkali. So important product is or the major product is primary amine and you get byproducts as carbonate and halide, like potassium halide, and here water. Okay, so one more thing you have to remember here. If you look the number of carbon atoms here and here, what is the change? Can you tell me what is happening and what is this kind of reaction called as? Is there increase in number of carbon atoms in the product or decrease compared to the original compound you have taken? Observe that. Yeah, it is decreased. So can I call Jyoti this reaction as descent of series? Yes, this kind of reactions are called as descent of series. Now, if you start the reaction with N carbon atoms, how many carbon atoms you will have here? Yes, yes, you will get N minus 1 carbon atoms. So this is an example for descent of series. Okay, good. So take an example. Earlier I took acetamide, right? That is the best example actually. So you take that only, CH3, C double bond O, NH2, write the reagents. Sometimes they will ask for Hofmann's bromide degradation, what are the reagents required? So tell me what are the reagents? Bromine and either potassium hydroxide or sodium hydroxide. Heat it, predict the product and remember the byproducts. As usual, byproducts will be K2CO3. You will have KBr as well as water. Can you tell me the name of the product? Yes. Just you remove this, that's it, degradation. Remove this in the form of carbonate, you are removing that CO group, that's it. So you will have CH3NH2, that's nothing but methenamine. So you started with how many carbon atoms in the beginning? 2 carbon atoms. How many carbon atoms you got in the product side? 1 carbon atom. So what is the nature of the reaction here? It's an example for descent of series. Okay. Understood. And one more important thing about this method of preparation is it's a very convenient laboratory method. It's a very good method. Convenient laboratory method this reaction is, and it gives pure amine. Preparation of pure amine, which is containing 1 carbon atom lesser than the original compound. Okay, this is the fifth method of preparation of amine. And one more method of preparation is there that is also important, which is a named reaction. So let's move on towards that. Okay, so the last method of preparation for primary amines or general amines, because only a Hofmann's ammonolysis you studied is preparation of mixed amines. Rest all we have studied is primary amines only. So this is a named reaction. You have Gabriel, phthalimide, synthesis. So this is Gabriel phthalimide synthesis. It's a named reaction. So let's write the general reaction. So what's the mechanism utilized? So here you have SN2 mechanism. So let me write the starting material. So see, I hope if you have learned the nomenclature, you know benzene ring directly attached to COOH. This is monocarboxylic acid, right? So if you have one more carboxylic acid group, for example, if we take COOH at ortho position, this is called as phthalic acid, right? So let me take the amide part of this. So I'm taking phthalimide. So write benzene ring, and you have imide. Imide is nothing but carbon which is attached to nitrogen. And you have a nitrogen, a lone pair of electron, right? So this is the starting material. So since it's a named reaction, it's very important also you have to remember what will be the originally reactant. because once you start with this only you can conclude it like what will be the product. So you have to remember what will be the starting material. So the starting material is phthalimide. So phthalimide means carbon and nitrogen is attached, so that's why we will be ending with it with imide. So on the arrow mark you take KOH now. So this reaction involves nucleophilic substitution reaction. It is a SN2 reaction. Uh, it's a nucleophilic substitution reaction. Okay. Now I'll take K plus and OH minus. This is the ionization part. Now you just abstract a H plus from this. Okay. So OH minus subtracts a proton and water is removed. Now can you tell me what will be the next product? Yes, what will be the next product? Tell me. You have C double bond O, C double bond O, and now you have N here, and this proton is removed. So on nitrogen, this pair of electron will be there, and that will be taken by K plus. Okay. Can you call it as potassium, potassium thalamide? Potassium thalamide. Okay. Now I got this. Now this is also preparation method of amine only. I have to finally get that only. Now what will I do? I will take an alkyl halide, RX. Okay. Now you tell me after removing this, alkyl halide, how it leaves? It's polar bond. So X minus. Now R plus is there, right? Now what will happen do you think? This K plus takes X minus and goes out as byproduct RX. Now you write the next product. You have benzene ring and it is attached to C double bond O. Next C double bond O and you have nitrogen here and you will be attaching R. So this is called as N alkyl group is attached for that, N-alkyl thalamide. N-alkyl thalamide, right? So now tell me, next step, if I do hydrolysis, what might happen? Both pair of electrons will be there. Do hydrolysis. This is basically a nucleophilic substitution reaction. Now remember, I took here alkyl halide. Can I take aryl halide in this example? Yes or no, you answer. Can I take aryl halide? Yes or no? Yeah, I have taken alkyl halide. Can I take aryl halide? Aryl halide means benzene ring should be attached to X. You can't leave this bond, so you cannot take aryl halide. Okay. Now you tell me yes, good, no. So now you do hydrolysis, break the bond here, add OH this side, H this side, break the bond here, add OH this side, H this side. Now what did you get? You got this broken part you observe RNH2, that is a pure primary amine, plus you get a byproduct also, that is nothing but benzene ring attached to COOH. This is nothing but phthalic acid. Okay. So my question is, now you prepared a primary aliphatic amine. Now my question is, can you prepare primary aromatic amine? Can you prepare primary aromatic amine here? For preparing aromatic amine, what should be there here? Aryl halide should be there. I already told it cannot be taken because you can't leave the bond. So can you prepare primary aromatic amine? The answer is no. So please remember. So if I take one example and try to show you the product. So take this. Take thalamide only. Take thalamide. With this you take KOH. Continue the reaction. You should get potassium thalamide. Potassium thalamide. Okay. Next you will get on the arrow mark CH3Br. This is alkyl halide. Can you write the next product? Benzene ring is there. C double bond O, C double bond O, and tell me the product. Byproduct is KBr. It went out. So you get methyl, N-methyl thalamide. So lastly, very good. So on the arrow mark, I'll write hydrolysis. So break this bond and predict the product. Yes, predict the product. What did you get? You got CH3 NH2 plus phthalic acid. Yes. Okay, correct. Okay, correct. So this is a method to prepare primary amine. Note, this is very important. By using this reaction, you cannot prepare aromatic amine because if you take aryl halide, it is not easy to cleave the bond. Okay. So this is all the preparation methods. Yes. Any doubts are there, you can ask me. So in this class, we have completed Hoffman's ammonolysis, which is a method to prepare primary, secondary, tertiary, quaternary amines together. So is that a good method? Since you are getting a yield, which is a mixture, it's not a good method. Second method I gave, reduction of nitro compounds. You take reducing agent, which works best as FeHCl, FeNHCl, because FeCl2 forms get hydrolyzed to release more and more HCl, so that even if you initiate the reaction with small amount of acid, the reaction is going to happen. So you get primary amine there. Then reduction of nitriles, it's a Mendius reaction, and reduction of amide, and lastly Hoffman's bromide degradation. And the final reaction is Gabriel phthalimide reaction. All these are for preparation of primary amines. Yes. Hope this class was beneficial for you. Any doubts are there, you can ask. I have completed the preparation methods. Yes, guys. Thank you, students.
Okay, thank you, Chaitra ma'am.
Yes, sir. I have completed one set of reactions, so I think.
So next time we have to continue the next one more talk on this
Yes,
same
sir.
topic. Hmm?
Yes, sir. Yes, sir. Chemical properties we can continue.
Okay.
Yes, sir. Any doubts are there? Students can send me the doubts.
Yes. Later on, I sent through the mail, ma'am.
Yes, sir. Yes, sir. Yes, sir.
Okay. Anyway,
Yes, sir.
delivering a very good talk on amines. Very informative and insightful talk on amines. ಮಕ್ಕಳಿಗೆ ಭಾರಿ ಸರಳವಾಗಿ ಅರ್ಥಗರ್ಭಿತವಾಗಿ ಹಲವಾರು ಉದಾಹರಣೆಗಳ ಮುಖಾಂತರ ಈ ಒಂದು ಟಾಕ್ನ ಚೆನ್ನಾಗಿ ನಡೆಸ್ಕೊಟ್ಟಿದ್ದಾರೆ ಮೇಡಮ್. ಸೊ ಬಿಹಾಫ್ ಆಫ್ KST and myself, ಥ್ಯಾಂಕ್ ಯು ಮ್ಯಾಮ್.
Thank you, sir. Thank you.
ಸೊ ಹಾಗೂ ಇಂದು ಹಾಜರಾಗಿರ್ತಕ್ಕಂಥ ನನ್ನ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಅಧ್ಯಾಪಕರು ಹಾಗೂ ಶಿಕ್ಷಕರಿಂದ ಮತ್ತು ನನ್ನ ಸಹೋದ್ಯೋಗಿಗಳು ಕೂಡ ಧನ್ಯವಾದಗಳನ್ನು ತಿಳಿಸುತ್ತಾ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ಮುಗಿಸುತ್ತಿದ್ದೇವೆ. ಹಾಗೂ ನಾಡಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ನವೀನ್ ಮಾಸ್ಕರೆ ಸರ್ ಅವರು ಸೆಮಿ ಕಂಡಕ್ಟರ್ಸ್ ಎಂಬ ವಿಷಯದ ಮೇಲೆ ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದು, ಎಂದಿನಂತೆ ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಲ್ಲಿ ವಿದ್ಯಾರ್ಥಿಗಳು ಹಾಜರಾಗಿ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ಕೇಳಬೇಕೆಂದು ನಮ್ಮ ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ತಿಳಿಸುತ್ತಿದ್ದೇವೆ. ಥ್ಯಾಂಕ್ ಯು ಮ್ಯಾಮ್ ಒನ್ಸ್ ಅಗೇನ್.
Thank you, sir.
ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ನಾನು ನಿಮ್ಗೆ ಇನ್ಫಾರ್ಮ್ ಮಾಡ್ತೀನಿ ಮ್ಯಾಮ್.
Yes, sir.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
Yes, sir. Thank you.